Okay, so let's pick up with this now. M squared minus 12mn. And I changed, this is the like the last example I did in the last video, but I changed this number, one number right here. Everything else is the same. All right, let's see if it is factorable now. Let's see, we got m squared. There's no GCF, by the way. M squared breaks up as m times m. This tells me the signs are different. Largest number. This tells me the largest number is negative. So my biggest number is going to go right there. All right, so how do I work this? To fill in the last two spots, you ask yourself two questions. I need two numbers. If you multiply them, you get 28. So let's see, 28, we've got 1 times 28, 2 times 14, and 4 times 7. Now I need two numbers that multiply to give me 28, but when you subtract them, you get 12. Now which of these three sets, if you multiply them, you get 28, that's all of them. But if you subtract the two numbers, you get 12. So that's that right there. 2 and 14. But the largest number needs to be negative. So you got a 14 and a 2. But notice, 2 times 14 is 28. But you got to break up the n square. So that means that I will put an n with this one and an n with that one. And if you FOIL this out, which we've done multiple times already, it will take you right back to where you started. So these problems can be prime. Now, let me show you an example of where you have to really make sure you understand the rules about the signs. So let's look at this example right here. X squared minus 8x minus 15. Now, here's what I want you to do for me. I want you to pause this video and I want you to work this problem. So pause the video now and work it, and then turn the video back on. Okay, now, hopefully you've worked this problem and kind of laid a trout for you, but the reason is I want to show you something about this problem. All right, so let's factor it. What's the first thing we look for here? A GCF. Is there a GCF? No. The next thing I do, this is the easy case, so I'm going to do two sets of parentheses. X squared breaks up x times x. What does this tell me? Signs are different. Now again, don't make the mistake of looking at both of these signs at one time. You don't look at both of them at one time. You look at just that sign. If that's a minus, the signs are always different. If that's a plus, the signs are always the same. So that minus there means the signs are definitely different. Now the last part is to fill in the last two spots. Well, we have to ask ourselves two questions. Question number one, I need two numbers that multiply to give me 15. Be careful right here. This sign right here tells you whether you are adding or subtracting in the problem. This sign right here. And that's why I tell you to watch how I point to it every time I do this. I need two numbers that multiply to give you 15. But when you subtract them, not add, subtract, you get 8. Now, if I was willing to bet, probably many of you out there has a 5 and a 3 in there right now. Now, before you erase it, I want you to do something. If you put a 3 and a 5 here, now the signs have to be different. So if you put the signs the same, it's wrong. But here's what I want you to do before you erase it. What I want you to do is pause the video now, and I want you to take your answer and FOIL it out and see if it takes you back to right here. So pause the video now and do that. Okay, if you pause the video and you FOILed your answer out, I promise you, you didn't get this right here. You got real close, but you didn't get this answer. Here's why. I need two numbers that multiply to give me 15, that subtracts to give me 8, not add. Do any of these two sets of numbers subtract to give you 8? No. 3 and 5 adds to give you 8, but it doesn't subtract. So there's not any. That's why this problem is prime. Let's do another one. M squared minus 3m minus 10. Okay? Look for a GCF. There's not one. Do your two sets of parentheses. M squared is m times m. What does that tell me? Signs are the same. What does this tell me? They're both going to be negative. Now, how do we fill in the last two spots? You ask yourself two questions. I need two numbers. If you multiply them, you get 10. And if you add, not subtract, because that's a plus. This tells you whether you're adding or subtracting. Two numbers that multiply to give you 10, that adds to give you 3. You say, well, 2 and 5. No. If you add 2 and 5, what do you get? 7. So are there two numbers that multiply to give you 10, but when you add those two numbers, you get 3? No, there's not. So that problem is prime. Now, if I take this same problem and change that one sign, watch now. It becomes factorable. Here's why. M squared is m times m. Signs now are different. Signs are different. Largest is negative. So I'm going to put the largest number right here. Now ask yourself the two questions again. Two numbers that multiply to give you 10, but subtracts now to give you 3. Multiply 10, subtract 3. 5 and 2 works now. But the 5, the largest number's got to be negative, so you put the 5 with the minus and the 2 with the positive. So see, you can change one sign and it completely changes your answer. All right, let's do two more examples. On this one, I want you to write these out side by side. Because this will show you, why you have to understand the rules about the signs. So this one right here, we've got x squared minus 10x plus 24. This one, x squared minus 10x minus 24. So the only difference in these two problems is this one sign right here. But watch how different it is. X squared breaks up x and x. This tells me signs are the same, both negative. Now let's look at this one over here. X squared is x and x. This tells me signs are different. The biggest one is negative. Now if that had been a plus, the biggest one would be positive. Now look how different these are. This one says two numbers to multiply 24, but if you add, you get 10. What two numbers, if you multiply, you get 24, but if you add those same two numbers, you get 10. 6 times 4. But look at this one. Two numbers that multiply to give you 24, but if you subtract them, you get 10. 6 and 4 won't work anymore, because if you subtract 6 and 4, you get 2. But if you do 12 and 2, 12 times 2 is 24, but if you subtract 12 and 2, you get 10. Now, you got to have a negative 10, so that means that 12 has got to be with the negative, and that 2 has to be with the positive. So that is factoring trinomials, the easy case. Now, let me show you how what I've been doing right now is tied in with something we did a couple of sections back. Let's look at this example. When you look at this example, if the first thing you think of when you look at this is you say, no, wait a minute, this is not going to be the easy case. I say, well, why not? And you say, well, because that's a 2 right there. You'd be correct. But remember, before you even look at a trinomial, before you do your 2 sets of parentheses, what is the first thing you always have to look for when you're factoring? A GCF. Now, look back at this problem again. Does this problem have a GCF? Yes. 2, 22, and 56. 2 goes into every one of these. So your GCF is 2. Now, you say, well, 2x. No, they don't all have an x in it. So your GCF is just 2. All right, when I factor out the 2, look at what I'm left with. X squared plus 11x plus 28. Now, before you stop, look at this. Doesn't this look just like the ones we've been doing? Yes, it looks like those easy case trinomials. So what I've got to do is if this thing factors again, I've got to factor it. So this is the first time you've seen me do a problem that factored multiple times. For this reason, the instructions will no longer say factor. It will say this. Factor completely. Because starting right now, you are going to run into multiple problems where it has a GCF and then it may go on down and factor again. So that's what we're going to have to start watching for right now. All right, so this one had a GCF. Now, here's what I need to do. I want to see if this factors again. Now, let me make a comment first. If it doesn't, if this doesn't factor again, I will circle that. So if it doesn't factor a second time, I'm not going to say prime. Why? Because prime means it didn't factor at all. So if it has a GCF, it can't be prime. So if it doesn't factor again, I'll circle this. Now, if it does, I've got to factor it again. Well, how do we know? I don't know till I check it. So let's check it. X squared breaks up x times x. This tells me signs are the same, both plus. I need 2 numbers. When you multiply them, you get 28. And if you add them, you get 11. 7 times 4 or 4 times 7. Doesn't matter which one you put where. Now, if it does factor again, it is very important that you don't throw your GCF away. It is just as much of the answer as the other stuff is. So now what I've done is I have found 3 things that multiply together to give you this. Now you say, Mr. Runner, how would I check this? If I check this, this is probably what I'd do. I'd FOIL this first and make sure that it gives you that. And then distribute the 2, and then it'll give you that. Okay, so let's look at another problem here. Let's look at this one. 9x cubed plus 36x squared minus 45x. All right, you say, well, this is certainly not the easy case. We shouldn't even be thinking that at this point. What you should be thinking at this point is, does this trinomial have a GCF? Well, let's look at it and see. 36, 9, and 45. 9 goes into every one of these. But that's not all. X cubed, x squared, x to the first. So I can take a 9x out of every one of these. Now see what we have left. 9x into 9x cubed would be x squared. 9x into 36x squared would be plus 4x minus, and then 9x into 45x would just be 5. So have I factored it? Yes. Have I factored it completely? I don't know, because I got to check and see if what I have left breaks down again. Well, let's look at it. Does it look like the ones we've been doing? Well, yeah, it looks like it. But that doesn't mean that it'll factor again just because it looks like it. So what I've got to do is see if this trinomial, because it's the easy case now, see if this trinomial will factor again. So let's see if it will. X squared breaks up x and x. This means the signs are the same. I'm sorry, signs are different. Signs are different. This says the largest is positive. So the biggest number is going to go here, unless it's prime. So how do I fill in the last two spots? I need two numbers. When you multiply, you get 5. And when you subtract, you get a 4. Multiply 5, subtract 4. Well, that's easy. 1 times 5. But the largest number needs to be positive. So I'll put the 5 here and the 1 there. But don't forget, if you leave that 9x out of your answer, it's wrong. So that is your answer to that problem. So when you factor these trinomials, look for a GCF first, and then look to see if it's the easy case. Now, let me show you one more example. I'm not going to work this one all the way through, but this will lead me into my next example, and it's this. All right, first, does this problem have a GCF? No. Can I do grouping? No. So there's no GCF, and you can't do it by grouping. Well, what's the only other option? A trinomial, if it's the easy case. Now, is this trinomial, is it that easy case? No. And the reason it's not is because of that 6 in front of that x squared. So if you try to do this one like you do the others, it's never going to work. So on this one, you can't say, okay, I need 2 factors of 2 that add together. That don't work. You can throw that in a garbage can. That only works when that first term in front of that x squared or m squared or t squared, all of that reasoning only works when there's a 1 here. So this brings us to a completely new problem. Well, remember when we started the trinomials 2 videos back, section 5.6 video, part 1, I told you, I said we're going to look at 2 kinds of trinomials. We're going to look at trinomials where there's a 1, and then the trinomials where there's not a 1. And I said, when there's not a 1, that's what I call the harder case. It is a more difficult problem. Now you say, well, wait a minute, Mr. Rand, the 2 problems we did right up above this one didn't have 1s. That's true. But they had a GCF. And when you brought that GCF out, it ended up being a 1 in front of it. There's no GCF in this problem. So the question is, then how do we find those two binomials, if there are any, that multiply together to give you that? That is a completely different technique, and it's called factoring trinomials by the harder case because of that one right there. We will give that a special name in the next section or in the next video, but this completes this video. So in your homework, your section 5.6 part A in your MyLabs Plus, 5.6 part A, these 3 videos pertains to that. Now 5.6 part B video will begin with the next probably 2 or 3 videos that I do with you together. All right, so that concludes this video.